Hi, everyone. Thanks for joining this session. So, as she said, I'm Moshe Tanach. I'm co-founder and CEO of NeuReality. We're an Israeli-based company with an office in the Bay Area in California as well. And our vision is to enable AI everywhere by introducing a new type of device and a new system architecture that we call network addressable processing unit. I'd like to start taking a moment to mention the difficult time that Israel is going through. Right now, being an Israeli company, we're obviously affected by what's going on in Israel. But I can tell you that we're staying strong. We're focusing on delivering, and let's send our best wishes to get back our children, parents, and elderly that are still kept hostages in Gaza. I'll end with a message, a campaign that runs in Israel. We're part of the Israeli tech, so important for the whole globe. We're working on science, for healthcare, for government, for safety, and we will continue to deliver. And with a sharp move, I'll move to we're somewhere in the continuum of AI compute. It took us 70 years to get from the first computer in 1943, mimicking the thought process, and Alan Turing test that helps us to check the quality of a machine learning compute until today that we have AI in production. Right now, in the past 10 years, us as an industry, we're focusing on building bigger, strong, supercomputer-like HPC cluster to run all kind of AI use case. The biggest problem is how to train models and how to do it fast, with high accuracy. But either when you have your model trained and you want to put it into production, you're still relying on the same very expensive, very complex hardware. And we do see some later versions of deep learning accelerators purpose-built for inference, but they're still using outdated system architecture. And I want to take you through some of the inefficiencies that exist today in the system architecture and how we're changing them. How we're bringing AI to a different level of inference at scale, deployment in much more market sectors. And I'll start from looking on how the data center look today. Today, if you look on the data center, we always had the compute, the network, and the storage. Now the compute is kind of separated. You have the primary compute, general purpose compute running the applications. And when you look on a large-scale deployment of AI, usually the application doesn't run the deep learning on the same server. It sends a request to an AI inference server that is holding the trained model and waiting for the response to come back. So if we Alexa application, for instance, that many of us are using in our home, actually voice is being recorded, sent to the data center in AWS, and then the Alexa application runs here. But then it communicates with 5 different backend servers back and forth for voice recognition, for language processing, for recommendation engines. If we zoom into how those systems are built today, you'll see the CPU-centric architecture. With CPU-centric, it was started 44 years ago because the CPU is in the center. This is where the server application runs and communicate with the clients that are sending requests. But the deep learning processing is running on the GPU or the ASIC, the DLA, deep learning accelerator. So what the inference server need to do, for every AI request, it need to go through network termination, getting the data from the client, then it convert it to an AI command. It runs some scheduling and queue management between the different clients that are consuming this. And only after doing some pre-processing of the data, it hand it to the DLA for neural net processing. So what's caused due to that is a tough bottleneck on the CPU, and this is the piece that limits the performance of the system. So not only that the economics of the server are quite ridiculous. For every dollar we invest in an L40 GPU or an AI-100 from Qualcomm, we're wasting $3 on the system around it. That limits the performance. So to summarize, we're looking on two very tough problems if we want to take inference to scale, if we want to lower the cost of ChatGPT from consuming $1 million a day to running at 10K or 50K, something that can allow us to integrate generative AI and inference in much larger market sectors. The way to do it is to work on the affordability of the system and to make it much less. The big hyperscalers or Tesla or enterprise can afford the big R&D to do the data science, the data science behind it, the deep learning engineering, the IT, the DevOps. But if you go to 7-Eleven, if you go to some of the banks, some of the filter enterprise, they don't have those capabilities. So when we founded NeuReality, we wanted to analyze the end-to-end problem of inference at scale and bring a different type of infrastructure and make it much simpler to deploy, to take your training model and integrate them into your digital infrastructure. So I'll take you to a couple of hardware slides and one software slide. This is the new AI-centric architecture. So remember the deep learning accelerators that were hosted by a CPU that's running in software, a lot of things. Now we have a linear scalability infrastructure that every DLA is hosted by one of our hardware chips that is offloading the data path, covering the networking, the sequencing, and the pre-processing in hardware, and really bringing, first of all, linear scalability. The diminishing return that you see in CPU-centric when you add DLAs, but you can't really utilize them, is disappear when you go to a fully linear scalability architecture. Now, why is it that important? Because when you calculate the two metrics that the data center care about, AI operations per dollar, the capital expending for the amount of equipment under it, and the AI operation per watt, per power consumption, the operational expense of the cooling and the power delivery network of the electricity below it, you see that when you go to AI-centric architecture, you can gain more than an order of magnitude improvement on both. And this is compared to GPU in a CPU-centric or in ASIC. And some of the ASIC here, some of the DLAs that Qualcomm, AMD, and others are doing show benchmarks of 3x, 5x better than a GPU. But when you put them in a CPU-centric architecture, you lose all the advantage. So you must move to an AI-centric architecture. Now, this is not enough. The data scientists, the DevOps engineer that sit here, all the ecosystem that is developing AI and deploying it, they can't partition their code between the different hardware components. So what we've done, we implemented 3 layers of software that cover the modeling itself, because some of those DLAs don't support some of the latest operands, so we offload them to our chip. We covered the pipeline, all the pre-processing and post-processing that are needed, because when you do face recognition, the actual media comes with a compressed image, JPEG. So you have to decompress the JPEG image, resize the image. All this is done on the NeuReality chip. And then the raw tensor is handed to the deep learning processor for the neural net processing, the heavy lifting deep learning. And the last layer is the service one. This is the first device. When it wakes up, it is a native Kubernetes device. We search for the AI, for the Kubernetes master, expose its capabilities, and it's ready for orchestration and provision. So what is it good for? It's good for computer vision applications, for language processing, and for recommendation engines. Each one of them is a huge market that is ready to explode. And these are analyses that are keeping open on an annual basis because we're doing more AI than what we thought last year. We're very much focused today on language processing, helping the big enterprise, the REP deployment, the financial services, healthcare, the cloud service providers. to do all kind of customer support applications, virtual assistant, document processing, with all kind of AI pipelines, from sentiment analysis, chatbots, voice bots, and more. And today, it's a very special time for us, because after a long 3-year journey, when we anticipated where inference is going to go, we started our journey that ends today with the launch of our products. And we're launching a full AI inference solution. We call it NR1 AI Inference Solution. And when we talk about solution, we talk about the chip that we developed, the first network addressable processing unit in the world. It's a category that I anticipate that we're going to see a lot of companies doing it in the future, and not only for AI, also for storage. It's the right way to do hardware, network, instead of just an accelerator that is piggybacking on the CPU. Then we have 2 types of hardware. You can buy it in a module form factor or with a full server with 10 couples of NR1 and any type of DLA. Above that, we have the software stack that simplifies the deployment process, but it's not a solution unless you have the ecosystem partners. And we're announcing today 3 AI-centric systems. The first one with IBM, their own DLA. The second one is with AMD, the V70 inference. And the last one is with Qualcomm, with the AI-100. So actually, customers can choose their choice of DLA, deep learning accelerator, integrated into our system. And we're right here. You can come and visit us in our booth. And what do you gain out of there? Oh, by the way, it's not only with DLA partners. We have Lenovo and Supermicro on the OEM side. We have CBTS and a couple of others that would yet expose their names, solution providers that provide complete vertical solutions. And we have cloud service providers who work there. So what do you gain? We gain full performance of the silicon invested in. If I'll give you an X-ray, a virtual X-ray of all GPUs that are across the universe, you'll see 30% utilization of those GPUs. So imagine the amount of cost we wasted and power consumption we're wasting for silicon that is deployed and underutilized. So performance and latency, scalability, ease of use, and you can now afford it. It's environmentally friendly. And even in real estate, I don't know if you guys know, but some RECs in the world, in Bank of America or JP Morgan, are being delivered with 13 kilowatts of power. If you put 2 DGX servers for NVIDIA, you cap them. You're at 12 kilowatts. So what do you do? Rest of the you just waste rec space and you build more and more rooms. So it's really a triple win. You win from the environment side, you win because you make a more affordable solution, and you win because you can scale as much as you want. So in this continuum of AI, I ask, what's next? What's next is NeuReality. We launch our NR1 AI Inference Solution. You can come, you can join us, and I'm inviting all of you to join us in our booth, but also in building the next generation of data center, more environment friendly, more purpose-built for AI deployment, and not just research and training of models, but really deploying them in much more market sectors and allowing more of us to use it, even if we're not AI experts. And this is what we do. These are the 3 systems with AMD, Qualcomm, and IBM. Thank you. I'll take some questions if you have.